Hello everyone. Today we are solving a question on automata theory, the concept of constructing the regular expression, then converting it to NFA, and then to minimize DFA. So what is the question given here? Construct regular expression, NFA, and minimize DFA for the language set of strings starting with A and ending with B over the input alphabet A comma B. Okay. So which type of strings it can accept? See, starting with A, ending with B, I can write this. Starting with A, ending with B. A, B. Starting with A, ending with B, I can write B, A, B. Starting with A again and ending with B, I can write A, B, A. This is also acceptable. Now see, starting with A, ending with B, and in between it can contain any combination. So I told you previously, in regular expression, for any combination we use closure, and since it is starting with and ending with V, we will use concatenation here. So what is our step 1? Our step 1 is regular expression, which is, now see, start, it can contain any combination between, so I will write A, B closure, starting with A, concatenating A in the front and at the back, at the end. If this, it can give epsilon also, means null string. So null string A B will give you A B, this. Okay, so this is our regular expression. Our step 2 is we have to convert the given regular expression into NFA. As I told you in the previous videos, I have posted the videos on converting the regular expression into NFA. We use Thompson's construction rule. So now see, this is closure. So what I will do, I will first draw A plus B, this okay, in center. Okay, now see, since it is A B, these all are epsilon transitions. This is a closure, so this epsilon from here to here, there is one epsilon transition. From here to here, there is one epsilon transition. Okay, we are concatenating A. I will write here A. This is our starting state. We are concatenating B. I will write here B. This is my final state. Okay, I will give the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. From 0 to 9 means we have total 10 states. Okay, so this is our step 2, regular expression to NFA. Now see, what is our step 3? Step 3 is we have to find NFA to DFA. For this we use a special method. Okay, so see, X, we are finding the closure y equals to epsilon closure of X, y of A, and I will write y of B. Okay, now see, y of A, y of B. As I told you in the previous videos, always remember, we have to take the starting state as X, epsilon closure of X. What are the epsilon closure of X? I have taught this in the previous video, so you can watch my previous videos of constructing regular expression to NFA and minimized DFA. I have explained what is the epsilon closure. You can watch that. Epsilon closure is of 0 is 0 only, because there is no epsilon transition, so itself. If I give 0 A, it will give me 1. and this here null. Okay, now see, this is a unique combination. I will take this one epsilon closure is, yes, it's L1 2 3 5, and from 1 there is 8. Now see, epsilon closure, I got this. Okay, now I will substitute. I will try to get the, I will check if there is a, it will make transition on getting a or not. Okay, now see, state A will receive A, there is any transition? No. State is state, this 2 is getting A, it will have any transition? No. 3 will have any transition? Yes. 3 is getting A, so going to state 4, I will write here 4. Okay, now see, 5 no, 8 also no. Same for this. C, 1 will get B, no transition. 2 will get B, no transition. 3 will get B, no transition. 5 will get B, going to 6, and 8 will get B, going to 9. Okay, this. Now I told you we have to take the new combinations. So since 4 and 6 9 is new combination, I will take the 4 first. Okay, now see, 4's epsilon closure is 4 itself. 4 to 7, 7 to 2, 2 to 3, and 2 to 5, and see, 7 to 8, 1 2 3 4 5 6, there are, this is 6. Now see, here 4 is receiving A, no transition. 7 is receiving A, no transition. 2 is receiving A, no transition. 3 is receiving a transition, is 4. 5 is receiving a no transition. 8 is receiving a no transition. 4 is, now I will check for B. 4 is receiving B, no transition. 7 is receiving B, no transition. 2 is receiving B, no transition. 3 is receiving B, no transition. This is a transition for A only. 5 is receiving B, yes, there is a transition of going to 6, and 8 is receiving B, going to 9. Now see, I use this for, I will use this combination 6 9. Okay, now see, I'm arranging this. Yeah, now see, 6 and comma 9, so it will first include itself. I will check the closure of 6. 6 to 7, 7 to 8, 2 3 5. Now see, 9 9, there is no closure. I will close this. 1 2 3 4 5 6 7. See, 6 1 2 3 4 5. Wait, it is correct. Now see, 6 is getting A, no. 9 is getting A, no. 7 is getting A, no. 8 is getting A, no. 2 is getting A, no. 3 is getting A, yes, it is going to 4. And 5 is getting A, no. I will close here. Same for this. 6 is getting B, no. 7 is getting B, no. 9 is getting B, no. 8 is getting B, is going to 9. 2 is getting B, no. 3 is getting B, no. 5 is getting B, 6. So I will 6 comma 9. Now see, I have taken this 4 here and 6 comma 9 here, but these all are same, means no new combination. So I will stop this step here only. As I told you in the previous videos, 9 is a final state. So if this contains, any one of this contains 9 or more, this contains 9, so that will be final state. Since this contains 9, this is a final state. I will mark with a star here. So you have to keep some space, so you can draw the star here. Now, what I told you in the previous videos, we will assume this as a states. Means we will rename the states. Renaming this as A, this as B, this as C, this as D. Now see, we have renamed what we have renamed. I am writing here on new page 0, this as B, this as C, this as D. Okay, we have renamed this. So according to the table, what we will get, we will write replacing these states. Okay, so A, B, C, yes, D will be star because it is final state. Yes, to write here this and this here. Okay, A, B. For A, what we got? 1. So 1 is B. So we will write B and none. So we will write 5. Okay, for B, we got 4. And here 4 is C. So we will write C. And we got here 6 comma 9. 6 comma 9 is D star. I will write here D star. Same, I got this CC and this D star, D star. Now see, we have to minimize it. Okay, as you can see, these both are non-final states and both are having the same transition, so I can minimize it. If these both steps are not same, means these both transitions are not equal, so we will stop here only by drawing the transition diagram. But since there is a minimization possible, so we will do that. Minimizing DFA, replacing B by C. B by C. So what I will do, A, B, A. B by C means I will delete the B row. C, D star. Now see, A is going to B means it will go to C now. 5, C, D star, C, D star. Just already same. Now what is the transition diagram here? A is our starting state. If it receives A, it is going to C. If it is receiving B, so no transition. Okay. If C, yes, it is going to C only, and D is our final state. If it is receiving B, going to D. Okay. Now D is receiving C, going to D is receiving A, going to C, and D is receiving B, going to itself. In this way, we have to convert from regular expression. We have to first write the regular expression, then NFA, then minimize DFA, then we have to draw the transition diagram. This is our final step. In this way, you can solve an example. It comes for in exam for around 10 marks. Thank you.